in this question, we have a uniform heavy rod of weight W. The area of cross section, length, and the Young's modulus of the rod is given. We need to find out the elongation of the rod. Now let us first analyze how the elongation occurs. With the gravitational force acting on this rod acts in the vertically downward direction, due to which a tension is developed inside the rod, due to which there is a stress developed in the rod, and due to which there is a strain, by the formula Y is equal to stress upon strain. Whenever there is stress, there will also be strain, therefore the length of the rod changes. We need to find out the elongation of the rod. For that, the first thing we should realize is that in this question, the tension throughout the rod will not be the same, due to which we cannot directly apply the formula of Y is equal to stress upon strain to find out the total strain and the total elongation. So what we need to do is that we need to integrate over the whole length of the object. So let us consider an element of thickness dx at a distance x from the top. If we cut this out, there is a tension T acting on this lower part of the rod in the upper direction, and the mass of this portion of the rod is equal to, this is L minus x. Therefore, the mass of this portion comes out to be equal to, that is rather weight of this portion comes out to be equal to W into L minus x upon L. Since the rod is uniformly distributed mass, therefore the weight of this rod, this portion of the rod, let us call this W dash, is balanced by T. Therefore the tension at distance x can be found out to be equal to W into L minus x upon L. Now the stress over here will be equal to W into L minus x upon L into A, because stress is equal to the force which is perpendicular to the area of cross section upon the area. Now we know that stress upon strain is equal to the Young's modulus. We divide the Young's modulus here to get delta L, that is the small change in length of this dx element upon the original length, that is equal to dx. So we multiply dx over here. This is the small, very small change in the length of this dx element. If we integrate this small change in length of this dx element over the whole length of the rod, we find out the total elongation, that is the summation of elongation in each of the small dx elements ranging from 0 to x, that is ranging from 0 to L. So we integrate this to find out the total elongation. Let us call this the total elongation delta L. This will come out to be equal to W upon AYL into integration 0 to L, L minus x into dx. This is equal to W upon AYL, L square by L square minus L square by 2. This is equal to omega L upon 2A into Y. So the total elongation of the rod under its own weight comes out to be equal to omega L upon 2A into Y.